Welcome to our mini project 3 for material science engineering class, in which we're testing the viscoelastic properties of polymers using slime and bouncy balls to explore how cross-linking affects material behavior. This connects with what we've learned in Module 4.2. Our names are Leire, Mariela, Ayala, and Sarah. Slime Part 1. First, I hold the slime with both hands and pull it apart very quickly. It breaks almost immediately. This shows how under rapid stress the slime behaves like a brittle solid. It doesn't have time to stretch. Now I pull the same slime slowly. This time it deforms gradually, becoming longer and thinner. This shows viscoelastic behavior. When given time, the slime acts more like a very thick liquid and flows instead of breaking. Next, I hold the slime with one hand and let gravity stretch it. Over time, it slowly flattens out. This is an example of creep, a time-dependent deformation under a constant load. Gravity pulls on the slime, and since it's viscoelastic, it stretches slowly over time. Now I pull the slime apart and hold it in a fixed distance. At first, the force needed is strong, but then it gets weaker, and the middle part of the slime starts to sag. This is an example of stress relaxation, a decrease in internal stress over time while the stretch stays the same. The slime flows a little, behaving more like a liquid over time. Now let's compare the regular slime with a thicker, more solid bouncy ball version. I try bouncing my homemade ball. It doesn't bounce very high. It comes back up about as high as where I dropped it, then bounces lower and lower. It's not super elastic, but definitely more bouncy than the slime. To make this bouncier version, I use less water and more borax compared to the original slime recipe. This increases the degree of cross-linking in the polymer chains. With more cross-linking, the polymer chains can slide past each other as easily. That makes the ball firmer and helps it keep its shape, unlike the slime, which is much more stretchable and soft. If I roll both versions into balls and let them sit on a flat surface, the slime slowly flattens out, while the bouncy ball stays round. This shows how cross-linking affects long-term shape stability. The bouncy ball has a higher Deborah number. The Deborah number compares the material's relaxation time to how long we observe it. Since the bouncy ball barely deforms over time, it acts more like a solid. The slime, which flows and stretches, has a lower Deborah number. Thank you so much.